Okay, let's do a problem where we take a quadratic equation and they ask us for a bunch of information about this equation, the zeros, the intercepts, the domain and range, and all that kind of stuff. Eventually they ask us to graph it. So this is like the homework problem where there's like 6 or 7 parts. So I'm going to use this function, f of x equals x squared minus x minus 6. So this is a quadratic equation. We know if we graph it, when we graph it, it's going to be a parabola. So now part A, in the homework, with this kind of problem, they ask for the zeros. Like we talked about in class, the way you get the zeros is you set f of x equal to 0, and then you solve for x. And just so you know, that's the same kind of thing we do when we look for x-intercepts. Just to make it very clear, if I took that equation and changed my f of x to y, so y equals x squared minus x minus 6, and I asked to find the x-intercepts, what would we do? We would set y equal to 0 and solve for x. That's the same thing we're doing up here when we find the zeros. So when they say find the zeros of x, or they ask you the x-intercepts, same thing. So to solve this equation, let's just go ahead and factor it. I think it's going to factor into x minus 3 times x plus 2. So my solutions are 3 and negative 2. So those are the zeros, although they're also really the x-intercepts. But since they asked for the zeros, that's what they want. But what's interesting, you get to part B, and what do they ask for? The intercepts. Well, I've already got the x-intercepts. I just found those. And I think they like you to write them as an ordered pair. So I would say 3, 0, that's my first x-intercept, and then negative 2, 0. Now I have to see if there are any y-intercepts. How do we find y-intercepts? You take your equation and set y equal to 0. So if this is my equation, y equals x squared minus x minus 6. I'm sorry, you set x equal to 0. To find the y-intercept, you set x equal to 0. You should have y equals 0 squared minus 0 minus 6. Y equals negative 6, which is your y-intercept. So then the y-intercept, written as a point, would be 0, negative 6. So there are your 3 intercepts. Now, the next thing they ask for, the domain and range. And at this point, they don't ask you to graph it, but I'm going to go ahead and graph this thing. They ask for you to graph it eventually, but I'm going to graph it now because it's easy to get the domain and range once you can see the graph. So if I plot my intercepts, I may be able to see what this graph is going to look like. You know what else I'm going to do? And they ask for this in one of the parts. Let me see, it's like, this is 3, 6. I think part C, find the maximum minimum value of f of x. That really is a problem found in the vertex. So let's just go ahead and find the vertex now so we can plot this thing. So here's my function. X squared minus x minus 6. You remember the vertex, I'll call it, it's a point, xv, yv. Remember the x of the vertex is that formula, negative b over 2a. So negative b is a negative 1. 2a, 2 times 1, looks like my vertex, the x of my vertex is 1/2. And to find the y of my vertex, I plug in the x of my vertex back to my original equation, and that gives me the y of my vertex. So 1/2 squared minus 1/2 minus 6. So 1/2 squared is 1/4 minus 1/2 minus 6. And now, if I combine these, this is like 2/4, so it's minus 1/4 minus 6. So I could write that as just negative 6 1/4. And let me check and make sure I haven't made any mistakes. I don't like these numbers, but maybe that's what it is. So negative b over 2a, negative 1 over 2 times 1, which is 1/2. 1/2 squared is 1/4 minus 1/2. It's negative 1/4 minus 6. All right, looks like that. So it looks like 1/2 negative 6 1/4 is my vertex. So 2, 3, 4, 5, 6. So 1/2 is about right here, and negative 6 1/4 is about right here. And let's go back and plot my intercepts. X-intercept was 3, 0. So 3, 0 is right here. The other x-intercept was negative 2, 0. And then the y-intercept was negative 6, 0. So it looks like to me, if I try and sketch this in, it may look a little bit like this. Probably won't be perfect, but so here's what we've done. So now, the domain and range, once you have a graph, domain and range is pretty straightforward. The domain are what's my smallest value of x from my graph to my largest value of x. Well, since this parabola keeps spreading out, the smallest value of x is negative infinity, and this thing goes to positive infinity. Now the range are the values of y. What's the smallest value of y? What's the farthest down this graph goes? And it's going to be my vertex. And it turns out it's negative 6 1/4. So negative 6 1/4. And it's going to go to infinity. So now, after the domain and range, I'm going to calculate the vertex, which I've already done. So the vertex is simply going to be, I've already done the math for that, 1/2 negative 6 1/4. And then they say, for what values of x is the graph increasing? Well, increasing is when it's going up, and it starts at the vertex. So the value of x increasing, it starts at 1/2, and it increases to infinity. And where does it decrease? It starts at negative infinity, and it decreases until you get to 1/2, and then it starts going up. So those are the kinds of questions they ask you for this equation, this quadratic equation. And it's not too hard as long as you keep things straight.